It's me again. Yes, a little more on electricity. Yeah, I left off with sort of the dilemma of figuring out why the DC current doesn't continue to flow, and I was a little unclear as to the mechanism. So, looking at the old drawing, which is a mess, yeah, there was also something else I wanted to fix. Here I did the crossover thing, with negative voltage versus a positive voltage. This ends up just being the neutral, of course, but you know, it's still meaningful in the sense that they're defining the poles. But I drew this line going all the way across, and I meant to go down the middle. So that's where the current switches over from the positive being on the outside to the positive being on the inside, and vice versa, which is very important to understand the switch over of the polarizing filter. So then when it came to the inducing currents, so this drawing was basically this is the 150 volts moving this way. It induces a current in the other coil, a voltage, sorry, that has the opposite polarity. Essentially, and in alternating current, it would basically be a phase difference. So when one coil's up, the other coil goes down, da 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 da. And so that's sort of the three-phase electricity and all that stuff kind of works on that kind of principle. But anyway, so I think I'll just redraw that quickly, just for clarity. So you have the two coils, and you have the current moving this way and this one, and it's the polarizing filter. So this is all strong here and weak here in terms of the voltage. Let's just say it's 150 volts. We'll do negative just for the sake of clarity, that these are too many electrons on the surface here. So all this wire has too many electrons on the surface. More electrons here than over here, which essentially creates a pattern, something like that you could expect in the field. Strong field here, weak field over on this side. I guess I could do this better, but no need to go crazy about it, right? Right. All right, so the weak field, strong field. So the tendency would be, obviously, if this field was pushing into this wire, it would tend to push this current here, and so you end up with 150 volts here, positive. No, 150 volts negative, sorry. So the excess electrons would end up over here. And if this was a completed circuit, the expectation would be, why doesn't it just start over again? Well, the problem is that the strong field is blocking it. It can't start over again. So that's one problem. So the first problem is the strong field basically is stopping the current from recycling. It's going through here again. The electrons can't get in here to get pushed this way. No electrons can get in here. So essentially they've been blocked in both directions. They can't come from either direction into this area because this is where the strong field keeps pushing. The other problem is that now that you've created a current in this other wire, a voltage, it is creating its own, what they call eddy currents. I think they use that term. But it's not really an eddy current. It's the reciprocal. Now that I'm an electrical force, I'm also doing the same thing, which is polarizing, and I'm polarizing strong where you're weak, and doing exactly this opposite thing you're doing. I'm trying to push your current exactly the opposite direction. They actually kind of talk about that way, that the current ends up pushing against the voltage. And that's basically what's happening. So that's why it gets stifled with DC current, is the DC current establishes a reverse polarity that essentially is like having the how to best describe it. I don't want to give it a magnetic. I want to keep it electrical. Um, but yeah, you're basically just creating a reciprocal that's opposite, and that is exactly not. It's going to inhibit you doing what you're doing just as much as you're creating what's it doing. So it's the equal but opposite reaction thing coming to roost again, you could almost say. So there's two factors there. The first factor is, even if it wasn't blocking the current here, this drag of the fact that it's creating a polarizing filter that's exactly opposite yours is going to negate the ability for either one of you to maintain a flow of current, because you're both going to basically be clogging the road, preventing progress. It'll reduce your secondary coil is going to reduce your primary coil's ability to move current or move voltage through current, and as your current diminishes, the strength of your polarizing filter, it doesn't move, clearly. I suppose your filter will be just as strong, but the point is it won't have anything to operate against, because the reduction in flow see, I guess the current flow isn't as important as the voltage, and as long as the voltage is being maintained. Yeah, so let's go with this being the most important factor is this block here. So the strong current, if it doesn't get turned off, this strong current blocks the ability of the electrons to go back this way, so they can't get back into the stream. So they're blocked from the reservoir, the stream, however you want to metaphor it. They can't get back in to complete this circular circuit. They just keep getting blocked here. And so all you need to do is have DC current that alternates on and off, but clearly it'd be more efficient if you alternate all the way back and forth between the two poles, because that way you ensure you clear the road each time. So you'll start over each time from a neutral by going all the way positive to all the way negative, so you get more efficiency. But clearly a transformer will work if you just use a pulsed DC current, but it won't be as efficient. So I don't think I need to add any. I think the rest of the video was okay. So that just explains that part of it. Again, it's just this. It's the same polarizing effect as in magnetism. The important thing is that whole idea of the twice is, and it's about acceleration too. Just the point to keep recognizing is that any current that's moving through the wire is moving because it's absorbed energy. It's absorbed the field energy, and it absorbs the field energy when it has the right polarization. Just like electrons absorb light of certain frequencies, they'll only absorb gravity, field force. Let's call it field force, maybe. Neutral field force, random field force. They'll only absorb that when it's the right polarization, and what they're really absorbing is the velocity. So you have to take basically the whole electron. Let's say the whole electron was 1 million quanta. If it absorbs a quanta, you divide the speed of light by 1 million, and you'll come up with the velocity that the electron is gaining. So it's a very direct, quantizable mechanism. And so, I mean, I'll work out math for that, but clearly the formulas that exist now already do that conservation. But the field is creating the acceleration, and it's creating acceleration by making the field absorbable. That's probably a good way to put it. Giving things directional imbalance. Yeah. So yeah, that's probably good enough. Absorbable in greater percentages. So again, it just has to do with this, the difference between the regular probability of impact versus double the probability of impact, and 0 probability of impact. So the fact that you have double and 0, again, you're dividing by 2. So you have 2 plus 0 divided by 2 is 1. 1 plus 1 is 2. Divided by 2 is 1. So it equals out conservation-wise. the probabilities in the end, but the point is that you're more likely to absorb the polarization that is of the kind that made it. So if you're an electron, you absorb polarization created by electrons. If you're a proton, you absorb polarization created by protons. Yeah. All right. With the 2x thing, and then you have the zero effect of the if I'm a proton and electron polarization is coming at me, it just goes right through me, and now I will be affected by the normal amount of gravity that affects me based on the random amount of correct polarization. See, that gets a little complicated because you got to understand the field is already polarized. It's just polarized in all the possibilities. And so there's a certain percentage of the field energy that's hitting me now that's of the right polarization to affect my electrons and to affect my protons. That's what it's affecting. But it has to be of the right polarization. And anything that makes it more of that polarization, more electron biased or more proton biased, will impose charge on me. Right, so if I'm getting hit by polarization that's electron bias, I will end up becoming charged if I'm not grounded. Meaning my electrons will gain acceleration. Okay, clear enough, I think. Alright, yeah, so we got electricity now. So we got electricity, we got magnetism, we got time dilation, we got gravity, we got inertia. We got it all. I mean, the electricity and the magnetism is basically, I'm talking about electrons and protons. We're already at the nuclear forces, essentially. Now I just got to diagram those. So we're 80% done, something like that. Anyway, till next video and such.